Hello. We are going to continue our discussion about Java object-oriented programming and data structures. So today we will move to chapter 15 about linked list. Chapter 15, linked list. For the book, you can find the link at Kendall Hunt Publisher. So for LinkedIn, for chapter 15, it's regarding LinkedIn. So the topics we are going to discuss is about introduction to LinkedIn. And we first are going to discuss the simple implementation of a singly linked list using nodes. And moving from that, we are going to discuss how to do iterable singly linked list implementation using nodes in Java, okay? Because iterable is a interface that is used a lot in Java, especially for like a collection related data structures. And we are also going to discuss about doubly linked list implementation with the list interface. Okay. And finally, we are going to discuss Java collections built-in linked list. So let's first take a look about what is linked list. So the basic information, okay, so introduction, the first section in chapter 15. So what is a linked list? So a linked list, it is an explicitly ordered collection of items, okay? And the information, so basically the items is stored. So each item is stored in a node. So linked list, the basic component building unit is a node. Okay, is a node. And then it's kind of you chain a number of nodes together, okay, and they are ordered, okay. So the first item then in the linked list is going to be contained in the first node, okay? And how do we chain them together? So basically a node has a pointer point to the next node in the sequence. So this concept is kind of like the railway train, okay? So the railroad train, okay? So at each car, the back of the car, there's a hook to the next car. So the hook is kind of like the pointer, okay, so point to the next node. So the node kind of like the car in train, okay. And over here, like he said, each node explicitly connected links to the next node. So in this way, to create, we call it a chain-like data structure. So it's a linear data structure, okay, but it's chained together. So the major operation in linked list, because linked list is one of the linear data structure, okay, and the for data structure, the key operation normally involve insert, so add a new item, or remove, so delete an item from the collection of items. Okay. And if you recall, we also learned other data structures is like array it can also be used to store sequence of items. So what's the benefit for linked list? So linked list, it allow efficient insertion and deletion at any point. So it's very efficient at insertion and deletion anywhere in the list, okay? But it doesn't have direct access to the elements. The quick access to the elements is to use index. Like in array, okay, you can do the indexing. So indexing is not possible in linked list. Okay, it's not supported. Okay, so for quick access, if you choose one of the data structure is like array, okay, or array list. But for linked lists, support efficient insert and delete. So previously we discussed, okay, about linked list. So we, in the second session, we will start with the simplest one. So that's a singly linked list, okay? So we are going to see how we implement the singly linked list, simple one, okay? And previously, we also discussed the basic building unit in a linked list is a node. Okay, so what is a node? So definition of the node. There are two parts in a node. So a node, so here it shows the diagram of the node. And you can see a node has two parts. The data part, the data part will store the item, the information contained in the node. And there is a second part. It's called the next. Okay. So what next? So the type, it's a reference. So it's an object type. Okay. So it will reference to the next node. Okay. So that you can chain them together. Okay. So this next field will allow nodes to be connected so that it's going to form a chain where one node links to the other and so on, okay? So that's the a visual illustration of the node. There are two parts, okay? One part contains the item value. The second part contains the type is node itself, okay? So it's a reference to the next. And the UML diagram for the node definition in Java. And over here, we discuss a generic type of node. So support any type. Okay. So the data type, it's be generic T. Okay. And the next, you can see it's still a node. Okay. And it has a constructor. So constructor is to create a new node with specified data information and a pointer of the node point to the next node. Okay, and once we understand the basic building unit node, then we can move on to see the singly linked list. Okay, so what here we mean singly linked list is the linked structure. Okay, it can only be traversed in one direction. So from the first node to the last. So keep this in mind, okay, traverse in one direction from the first to the last. So the UML diagram for the linked list in our implementation is as follows. So here what we define the linked list for the type, it's generic type, okay? But because we are going to form the linked list in ascending order, okay? So that's why here we let this type also support the comparable, okay, interface. So that's why here we do the extends comparable, okay, for this generic type. So this generic type must support the comparable interface, okay? So for the linked list, it's data member, so basically just one data member first, and the type is the node, okay? And for its member method, we include the constructor. Okay, so generally speaking, for the constructor, what it does is create an empty linked list. Okay, Then we have a member function called isEmpty. So to check if the linked list is empty. And we do the insert. And here, uh, uh, for our implementation, we follow the rule to insert the new item into the list in ascending order. Okay, so because of this, that's why we have this comparable, okay, to determine where we are supposed to insert, okay, and remove. So you find the item and then you remove it, okay. And we also have the function to string, okay, and it will return a string which consists of the item from the beginning to the end. Before we move on to the code, so let's first take a look the operations, okay, in the singly linked list. So when we do insert, there are a couple of scenarios we need to think about, okay. For the insert operation, okay. So at the very beginning, when the list is empty, when the linked list empty. Okay, so then basically you're going to create a linked list of just with a single node. Okay, so the way to do it, you need to set its only data member. So first, it's the only data member of the linked list class. So you just set it to this new node. So you also need to create the new node. Okay, so we are going to see an example, okay, in our implementation code. So that's the first case when the linked list is empty, okay. So the second case is you insert at the beginning that. So in this case, suppose 50 already insert. So you're going to insert 30. So in ascending order, then 30 is going to be ahead of 50. So it will be the first node in this case. So originally first is 50. So what you do is you need to create a new node that has 30, etc. After that, then you need to reset first to new node. So like in this diagram shows, so that's the second option, second case. Okay, then the third case is insert at the back. Okay, the insert at the back, so it involves, because for linked list, so you always start at the first node, because that's the only data member you can access, the first node. So the way to do it, you need to do node by node moving. Is it like you are in the train at the first cart? You need to move all the way to the last car, okay, on the train. So here, this kind of moving, we call it move from one node to the next node. We call it traversing. So you need to do the traversing, and to do the traversing, you can use some variable, okay? We call it a cursor. So cursor starts at first. So you initially set it to the first. Okay, what you can do in coding is you just do cursor equals to first. Is it? So how do you move to next and next? Is it? So you can do the move. We call it advance to next node. So how do we do it? It's you just do cursors next. Okay, so you access it's next. Is it because it's next? Then it's 50. So cursor here, and then you move on as it's next. Okay. So the third case is you insert at the back. The insert at the back so basically is the last node. So how do you identify the last node? So last node's next is null. Okay, is null. So you can determine, okay, when cursor's next, if it is equal to null. Is it? So if it is null, then it's the last node. Okay. Okay. Then you know the last node. So what you can do is you just set cursors next to the new node. So then you add the node at the back. Is it? Okay. So the next case, yeah, here it shows how you advance the cursor. Okay. So we already discussed. So the next case, it's the fourth case, is it? So it's insert. Oh, here is insert in the middle of the linked list. So in the middle, so the same thing is that you need to do traversing to find the location for insertion. So like in this case, is it okay? It find, okay, cursor. So we are going to insert after 50 because we going to insert 55. Okay. So this new node already created. So the new node is it? So node, new node. You need to do that new node. The new node and with the information 55 and null. That's how you create this new node. So after you create this new node, and also remember this new node where it created, it's created heap memory, is it? So once it's created, you find the cursor. So what you can insert is, okay, you let the new nodes next. So you need to update it. New nodes next should be the node you're going to insert after its cursor. So cursors next. Okay, yeah, so point to 90 is it. So it's point to the new node. And then you need to update a cursor next. So cursors next, then need to be the new node. So in this case, then you can insert 55 between 50 and 90. Okay, and so the most two important operation in the singly linked list is insert. So we already discussed. Another one is remove or delete, we call, okay, generally. So for the delete, the same thing. There are different scenarios. Is it you delete the first node, you delete the last node, or delete in the middle? There are different scenarios you need to think about. Okay. So here we consider deleted in the middle. So somewhere in the middle of the linked list. Is it? So uh, how do we do it? Is it how do we do it? Is we're going to delete node 30. Is it? So you need to find to locate the node. Locate the node. Because you're going to remove it from the linked list, is it? You cannot just remove it. So there is also involved the operation is you need to connect the one before it with the one after it so that the chain is not broken. It is the linked list is not broken. So that's why when we do delete, we need another variable, node variable. We call it previous. Okay, previous. So it will remember the node that's before the current node. So basically, this is a pair. They always move together. Okay, so previous and current, it's a pair advance. So the first, this is current. Okay, and so in at the beginning, at the beginning, and at the beginning, this is just a no, okay? And then current need to move to next, and then previous need to be the current, etc. So how do we do the pair advancing is then you do previous equals car, and not equal, assign to car, and the car equals cars next. So this is called pair advancing. Okay, pair advance. Okay. Because of the pair advance, okay, after that, after you locate the cursor, you locate the cursor, what then you can do is you just set the previous next equals to, not equal, assign it to cursors next. In this case, this is going to be removed from the chain, okay? So that's the general idea, okay, about the remove in the middle. So it's a little bit of more complicated than insert because it's involve the pair advancing. So you advance both previous and the cursor, okay, together. So over here, we further discuss the pair advancing, and we also discussed how to do the traversing. Is it for the traversing, you can use the loop if you want to loop through the whole linked list. Is it? So the loop variable type is a node. Normally we call it the cursor. Is it? It's set start at the first node. And when it reaches the end, it should be null. So if it's not the null, then you just do cursor equals to cursor.next. So this is called advance cursor to the next node. Okay, so let us, for this lecture, let us stop here about the concept of simply linked list and the visualized illustration about the linked list and the basic insert and delete operations. Okay, and we will come back to discuss about the implementation in the next video.